YouTube. YouTube should be live any moment. Yeah, it's public any moment. And YouTube is live. And hello to everyone. Our goal for today is to have a simple OpenGL project running using CMake in Debian. The last 2 streams we learned how to use CMake. And the first task will be to build and compile GLFW. This is so GLFW is used for Windows, like to have a Windows where we can actually render in OpenGL. And like last 2 streams were on CMake, and I, as an off stream, I compiled OBS Studio. It uses as well CMake. Like, I think this is interesting to mention. That's why I'm mentioning it. A quick side note. They use CMake. Here they have CMake list. And I compiled it just so I can combine it with this plugin. And it had in the guides to build OBS Studio. And to check out all this code inside of like OBS in the front-end folder, and then to add subdirectory in another CMake list, and then to rebuild OBS Studio. There's a simple way to install plugins. That way on Debian with this plugin didn't work because this plugin uses an older OBS version. And here I went to an older version of OBS. I downloaded that. They're on releases precompiled versions, and I could download it from there, but there weren't any ones for Debian. There were for Ubuntu, but not like binaries for Debian. And so yeah, I used what we learned from the last 2 streams, and here they are. I tried it with all kinds of different versions, and the interesting part was in OBS Studio 31.1, and in here I had to create a CMake user presets. So nvim CMake user presets JSON, and here I made one preset for Debian, and I set it to be like to use the NVIDIA and to be portable, to be a portable build. And I had to download some packages and like do the regular commands as like CMake preset, and then this Debian preset, then CMake build in the build folder. And yeah, I kinda used what we streamed in the past 2 streams. And now we'll do quite similar thing with GLFW. It's also a CMake project, and we'll be also building it, just like I did with the OBS project. And luckily they have a guide on how to do it. And we'll follow the guide. First, we'll build GLFW. So for example, in the dev folder, we'll be cloning probably the code of GLFW. They have binaries, but I want to actually compile it with CMake, and I'll have it as a sub-project to the main OpenGL project. So using CMake, GLFW behaves like most other libraries that use CMake, so this guide mostly describes the standalone configure, generating and compile sequence. If you're already familiar with other projects, you may want to focus on installing dependencies and CMake options. Dependencies, okay, we'll be downloading here dependencies. By default, both Wayland and X11 backends are enabled on Linux and other Unix systems. To disable one or both of these, set GLFW build Wayland. Yeah, we'll have to disable this one. In the next step, when generating build files, to compile GLFW for both on Debian, and we'll not be compiling for both Wayland and X11. We're using X11, Debian at least. On Debian and derivatives like Ubuntu and Linux Mint, you will need the libwayland-dev and the libxkb command dev packages to compile for Wayland and Xorg-dev. This will pull in all other dependencies. Xorg-dev. Okay, let's just install this. Okay, while it's installing, this is for Fedora and other ones as well. Generating build files with CMake. Once you have all necessary dependencies, it is time to generate the project files or make files for your development environment. CMake needs two paths for this. The path to the root directory of the GLFW source tree, the path to the directory where the generated build files and compiled binaries will be placed. If these are the same, it is called an entry build, outer build. Outer builds are recommended. Okay, a common pattern when building a single configuration is to have build directory name build in the root of the source tree. Generating with CMake GUI will not be using, command line. We'll be using command line. Okay, so this is what we have to give. Path to GLFW and path to the build. Okay. GLFW's GitHub. Let's download the source. Let's clone it. Git clone. And cd in glfw ls. Fine. Now, run make. But we need, is there a, what do we have inside? We have, yeah, okay. We have to build it. CMake, let's say here is the source. And the build is build folder. Okay, we have the build folder. By default, GLFW will use Wayland and X11 on Linux and disable support for one or both of these. Set GLFW build Wayland option. Okay, let's remove. Let's build it again. Like, but setting this option Wayland to 0. I suppose this will be like false. Okay, we've built it. Move on to compiling the library. Now let's compile it. Yeah, we can just do like in the previous streams, this thing. Okay, we've built GLFW inside of the build folder. And let's check it out. What from here are we going to use? I think this file. Okay, we've built it. The CMake files for GLFW provide a number of options, although not all are available on all supported platforms. Some of these are... If you're using the GUI version CMake, I'm not. Finally, if you don't want to use any GUI, okay, shared CMake options. Is built as a static library or as a DLL? This is disabled by default. Producing a static GLFW library. Yeah, we'll be using it as a static library. If you want to change the library, okay, GLF library type, build examples, tests and documentation, okay. Yeah, in the build folder we had examples, and if we don't want them included in the build folder, we'll set up these flags. It is for Windows. We set this accordingly. Cross compilation with CMake and MinGW. Compiling manual, okay. Yeah. Build and compile GLFW. So doing done. This is done. Build and compile GLFW is done. And it's ready for use. Now let's build and compile GLUT. GLUT is used so we can have access to OpenGL. So we can have access to OpenGL because usually you can use OpenGL without GLUT, but GLUT makes it a lot easier to use OpenGL. We can say it in that way. Because OpenGL is a specification and GLUT, and it's just that. OpenGL is just a specification. And for our code to know how to access the OpenGL implementation in the graphics drivers, we need GLUT. And GLUT is this repository. And it can be built using a generator like this web service. But I want us to build it with CMake. And I think they had a guide for that. Yeah, this wiki. Let's download it. Git clone. cd glut ls. And let's see how to use it. This is the usage. CMake. The GLUT sources from the online generator. Okay, this is if we use the online generator, then in our CMake, we will just have to copy paste this. But this is to generate it during the build process. Everything that this automates the use of going online and doing all of this. The reason we're doing it this way is because when you're first time starting, you can use the online generator. It's easier that way and faster. But doing it this way, you may want to change the OpenGL version you're using to make you will have to use a different GLUT, or maybe you want some kind of an extension, and having a simple file that you can quickly change and then just build everything and everything works. You don't have to download anything. This is just automating everything. Do they have here? No, there's no CMake here, CMake list. What about in GLUT? Nothing. CMake CMake lists txt, and let's suppose we copy paste this. Oh, but this is like our own project, and this is the path to the... Okay, this is in use of our own project. Okay, this is not the proper way to do it. Okay, we can we have here create a simple hello world CMake project and then link GLAD and GLFW to it. We'll jump to this task and then we'll do this task of build and compile GLAD. Let's go backwards, ls, and let's make a new dir, simple OpenGL project. Okay, we've created a simple project. We can make a main CPP file, and I have one simple C++ main CPP file from previous projects. Let's see this hello world. Okay. In the main, you don't even need to return anything. Now, let's make a CMake lists txt, and we can actually use from the CMake tutorial some presets. In CMake, in step 0, from here. Like this is like very simple. Okay, here like the version of CMake that we'll be using, and this will be the project. Simple OpenGL project, and it will have an executable. Application. My app, let's say. And we will give to the executable this main CPP file. And that's it. So CMake be built and CMake build. So this just built using CMake the project in the build folder, and this I think compiled it and created the executable that we can run with my app. And here it is, hello world. Here it is. And now let's add GLAD. And yeah, with external GLAD. Okay, let's do it this way. Make dir external. Make dir external. No, we can just clone the GLAD repository there. Do we have it? Like git clone. Nice. And then not vim. Then we can edit the CMake list with this. But there's a difference. There's a difference. So, and here it's using C. My project is not using C. Add subdirectory CMake. We'll see if it will cause a problem. Find package. What does find CMake find package? What does it do? Does it like automate? Find a package usually provided by something external to the project, and all this. But how does it find it? Custom modes, module and config mode. You're trying to use module mode when you actually need config mode. Also find is okay, so it like it's trying to locate it either within the project or outside the project. Yeah, I don't want that. Path to GLAD directory. Path to GLAD directory and add subdirectory. Okay, let's have it here. And this will be wait a minute. External GLAD, is it like no, they don't have an external folder. Can we just do like this, external GLAD? And it will look for CMake. Okay, add executable, we have that. And we will link the libraries. Now what will happen? GLAD library. Error at line 15, target at the linking. Cannot specify link libraries. Oh, I forgot to change here. It should be like my app. And then build can do cd. Okay, it cannot cd2. Let us try to cd to it. cd home dev simple OpenGL project build. Oh, it's the path we gave it is in it's looking for it in the build folder, I see, not in the source. in the build folder. Here is my app. So it's looking for add subdirectory. Like add subdirectory should be let us look at the CMake tutorials from previous streams. Def, ls, and where? cd CMake and cd step1 and vim. Like I want to see from previous times. Add subdirectory tutorial. So it should be like path to CMake files. So it should be external glat and CMake. Oh, what's the problem? No module named. Hmm. We could specify this. Because I didn't add it. Let's do a clean build. Still the same problem. Okay, it's actually compiling the glut. So it's going in the proper directory, external glut, but some kind of a Python script. Is having an error. We can always just go back to the online generator and to skip this part. So this is setting OpenGL to be core, OpenGL core version 3.3. Module not found. CMake current list dir. Include glad config CMake. This project defines a glad add library function that will create a glad library. Created library will automatically generate the glad sources. Consumers can link to the library. GL profile core version 3.3. Yeah. Of in glad, then glad again. In glad and then glad again. And the issue is with these Python files. Gene Ja2. It's not inside of here, it's in okay. We can just generate it with online generator. So this is for C++, core. Let's do the newest version of OpenGL. Yeah, core. No extensions. Generate. And let's download the zip. And let's go to our project that we're working on. External. Let's delete this glad as it has never happened. And what is the example? It's to they include current source directory. Include directories. Glad include and glad source. Okay, so we make a folder, new folder glad, and let's just extract it there. Home, dev, glad, not there, simple, OpenGL project, external, extract, new folder glad, and let's move it here. And let's edit the CMake. And let's just copy and paste this. Remove this. CMake current source dir external. And then external. Now let's build everything. CMake build. And it worked. So let's run it. My app. It's running, but we're not like actually testing to see what's up. So we need to add GLFW as well. We need to, let's copy it from here and external paste it here. And then how to actually use it. Let's do add subdirectory. So external GLFW. Okay, it built everything. Now, let's see if we can actually use it. Let's find a simple GLFW example. So it's just using GLFW. And let's make, we need, and NeoVim is struggling to find like the header files. We need to generate, forgot the name of it, but it was, I'll copy it from a previous project. It's just a single line. It was in I think it was here. Yeah, this part. To export compile commands. Oh, we have to do like a base dir, etc. Here, let's see now. Here, like let's see. Kernel GLFW. What are our options? Come on, man. I have to change parts in the CMake probably. Here inside the tutorial, we managed to do it. Like here, we managed to include the header file from math functions. Here, the header file is public. And in the whole project, we just had to add the subdirectories. The stream is going fine. Okay. Include. Okay, we have the GLAD folder. We have GLAD. We don't have GLFW. Yeah, we can include GLAD. We have add subdirectory. Let's go CMake tutorial. And in step 2, no, it was step 1. They had something like that. Target sources for the library. Base dir include. So that we could include just what we needed. But here is different. It managed to compile, I saw it. It managed to build and compile GLFW. I saw that. we just need and we have compile commands. Oh, we have access to this GLUT. Yeah, this is what we have access to. It's not like this GLUT folder. It's this GLUT folder. And for GLFW, include GLFW. This is what we want access to. We're just missing one like command somewhere. No such file directory. Yeah, it cannot find like it cannot find this folder. It cannot find that folder. We can just look at the documentation for GLFW. Like we managed to handle GLUT. We just need GLFW. GLFW. Yeah, we've managed to compile it. Oh, but we need to set Wayland to false. Here. Set Wayland false. Now let's try. No, this is different. This is we can just do it like here. External GLFW include. Yeah, this will be enough. Okay, let's just quickly see inside of here. Look how now we can include GLFW. But there was some kind of another error. In function, undefined reference to GLFW set window should close. To set error callback. Okay, for we are not linking. Like we've included the header, we are compiling the GLFW, but we just need to actually link with the static library. And that should happen with, let's do this. After target sources. We link my app with what is the name of the library? At yeah, at library. Here it is, GLFW. Is GLFW. Let's build. They are still undefined references. Oh, this is different. This is OpenGL. This is OpenGL. Yeah, GLFW. Yeah, we solved the GLFW. It didn't manage to compile. Geo get string. We need to remove that as well. Be right back. Okay, I'm back. CMake. Yeah, and so we run my app. And that's it. We have... That's our window. Yeah, this is our window. Now, man, finally. Let's delete these error callbacks, key callbacks. I want this to be simpler. Create window. Yeah, let's glut example. They had a simple example. let's copy this example. Now, let's compare differences. Yeah, creating a window. GLFW init. And these hints. And make context current. And we delete this. Now, this should be above that. But when I save, like, the formatter messes things up. Clang D ignore. There was a comment that you can write so that Clang D ignores the formatting. Disable. I think there was, we can do it in a different way as well. It's not like it has to be done by telling the formatter to not reorder them. I think in the header there was like one define we could make so that it's not a problem, but there was another way as well. There are couple of ways to solve it. Yeah, let's make a clang format file. This is just for my personal formatter. And it needs sort includes false. Here, now it doesn't do it. Exit failure, let's just std. What's the problem? Yusuf undeclared. And what's exit failure? Unqualified ID. Okay. Create now width and height. Constant. Can make them global. Const static int width. 1920. 1080. And that should be it. Of course, that's not it. No such file. We went through this before. Yeah, now it's different. Undefined reference to glut load GL. Isn't it just the same problem as before? Where we have to link? But glut didn't, it had, is just a source and like includes, doesn't, it's not as if it has some kind of a library. Yeah, we're including the C file and we have the include folder. We're linking with GLFW. Glad load GL. I think most likely it's just our example is a problem. GLFW documentation. Yeah, we can compile GLFW. I want to test the OpenGL. Yeah, glut. This is the define I was talking about if the order is different. I'm confused. Undefined reference to glut load GL. Isn't it? Glut load GL is a function that we're using. It should be defined in here. GL glut load GL. Yeah, this is it. It's in the header that we're including. And in the source, glut load GL. And here it is. This is it. Oh, yeah. Let's include it here. Yeah, let's include it here. Yeah, that's why it's undefined. Confine, Like we need to include it in some way. Current source dir. We can just comment this out. And in here, just have the external glad source GLC. Okay, and it's done. And so build my app. In the while loop, let's geo clear color. We need different example. Like we need to clear the. We need to clear the screen. But I want an example. Geo clear color and depth buffer. Okay. Geo clear color, like it was gel color buffer bit. Yeah, just the color. And gel set clear color. Clear color. Let's do it red, green, blue, alpha. CMake. Neovim, CMake. There should be like some kind of easier way to build. Like I remember in the documentation. Neovim doc CMake. Okay, we'll just do it like this. Yeah, now we have a red as a cleared color. And we can make it like a floating window. This is it. From our to-dos, build and compile GLAD, create a simple Hello World CMake project, link GLAD into the project, render a window, and now let's render a triangle. And as a to-do, how to quickly build and run the CMake project. Fix 3-seater syntax highlight missing. Now let's render a triangle. Let's change the clear color again to like we can try like a gray color. This should be gray when all the red, green, and blue are the same colors, or like 0.3. I don't know what the color will be in the end. And so for a triangle, we will need, oh no. For a triangle, we will need shader, we will need vertex array, vertex buffer. The shader is the annoying part. Is there a way to do it more quickly? OpenGL shader. Wiki. There was an example code for a shader. Compile. Yeah, this part. Let's do it. Why not? Add shader CPP. And shader H. Pragma once plus shader like this. Public private uint32d. I'm sure this is like an unsigned integer. That's what I've learned to use. Unknown type name. Unknown type name uint30d. Okay, people are saying to include std int. And that fixed it. So here shader. I'll try to do it in 15 minutes. We need void bind, unbind, and here like std string source, like a vertex source, std string fragment source. We will not be like using file paths. Include iostream. Will not be using file paths, it will be directly a string. And in the CPP include shader H, shader 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 shader, and in CMake list here we will have shader CPP and shader H. In okay, it compiled. Man. Yeah, now it finds the shader thing. And now we can actually use the source code. Here everybody copies it. Like, you're not expected to know it by heart. And vertex source fragment source. Include glad GLH we can do it inside of there and include a vector. And there's no syntax highlighting here, sadly. If when I fix tree-sitter, there'll be probably syntax highlighting or some other like package. Now, it's getting the sources. It's where is it creating the shader program? Create program here. I want it to be like this will be like our m renderer ID, and here it will be like m renderer ID. Attach shaders, detach shader, fine. Geo delete program. Geo delete program. And now we need the reference to the program and bind geo use program. Geo use program m renderer ID renderer ID, and unbinding it we just use the 0. And for the main we will before the main loop, we will create a shader. So a shader, we need to include it. Std string vertex source and a fragment shader, and we will give them to the shader program. And here I think it was possible to do it like that. Like C++ string multiple lines. How did they do it? So this is here. And this is there. Yeah, like that. That's how we can do it on multiple lines. And this like that. And now we need a vertex source and a fragment source. Simple vertex shader. I need simple shaders. This is a simple shader. We will... We can test it out without even using a vertex array. No, we'll not use a color. We'll use an array of positions. GLSL arrays. How is an array defined? So the type and how do they set the values? Like, I think it was like like this. And the three vertices we'll be using, I think. M vertex ID GLSL. And so the position will be the positions using the GL vertex ID. That will be the shader, and here like the positions like minus 0.5 on the X, like 0 on the Y, 0 on the Z, and the next one will be to the right, and then in the center but on the Y it will be like a 1, let's say. And let's do a fragment shader. I think it had an out color like vec4, and then like color, it can be like a red color. Let's just try it like that. And GL draw arrays, molds, GL triangles. First 0, count 3. Let's do it like that. We have the gray color, but we don't see anything. We don't see anything. We should check for errors. No errors. So I assume the shaders have compiled. We can test it. Oh, we're not binding them. No, that shouldn't be an issue. Let's do a mistake on purpose, like forgetting this one. Build. No errors. That's bad. There are for sure errors in the shaders. Let me check. What is the constructor doing? It should be checking. If compiled false, get info log. Get info log. But we are not printing it. Right? Yeah, we're not printing it. The out info log std and line. Like that, and here as well for the fragment and for the linking. We can do a printf, like, doesn't matter. Like, what was infolog? Oh, a vector of GL characters. Vector of GL char. How? Vector of characters. C++ print vector of characters. I don't know how to print it. Where did I get the code from? From here. Scout, like, let's do the, like that, let's do it like that. Okay, finally. Void expecting. Syntax error. Unexpected reserved word void. But I need to know where it's coming from. Vertex shader error. Fragment shader error. And then linking. Shader linking error. A vertex shader error on line 6. Here. Yeah, this part. Syntax error, unexpected reserved word void. What's the issue? Oh, maybe when I'm defining this. Yeah, when I'm defining it, I'm probably making a mistake. GLSL. Array. Yeah. It's missing the semicolon. Oh, fragment shader. Why? Line 5, syntax error, unexpected reserved word void. Oh yeah, when we define the color. It's the same for it as well. Main. Here. Have to build, to compile it. No errors now. There are no errors. let's just to be sure create a vertex array. Or to bind the shader. Shader. We have to use the program. Okay, here it is. Finally. Oh my god, it took a while. It took a while, man. Oh my god. What I did coding the shader, it's like it's you're not supposed to do it in this way. Like you can look at references, you can look at other people's code. I just wanted to quickly make a triangle. Yeah, so we have everything working. Finally. Bro is streaming for himself. I'm just super focused on the project. Okay, that's it. So thank you for watching and see you next time.